Tonight, I want you to try something different, something gentle but radical. Close your eyes, unless you're driving, and imagine you're floating in space. No rockets, no suits, just you, suspended in a stillness so vast it swallows sound itself. From this vantage point, we're not going to explore the solar system or fly past galaxies just yet. We're going to do something more fundamental, something that quietly dismantles how you see your world and yourself. We're going to ask, how small is Earth really? And no, I don't mean small compared to Jupiter or the Sunday. I mean truly small. Small in the way that defies intuition. Small in the way that, if you could see the scale of the universe all at once, Earth wouldn't just seem insignificant, it would all but vanish. Because here's the quiet truth. Earth isn't just a small planet. It's an almost imperceptible speck, hidden in a reality so immense, so deeply structured beyond human comprehension, that finding a metaphor, any metaphor, to capture it becomes almost impossible. And yet, we're going to try. Before we dive in, take a breath. This isn't a science lesson. It's a meditation. It's a soft rebellion against everything that ever made us feel like the center of things. It's about humility and wonder. Now, let's begin. Let's start not with black holes or galaxies, but with Earth itself, the home that bore every one of your memories, the solid ground beneath our feet, the air in your lungs. From the surface, Earth feels enormous. You could live an entire lifetime and never step foot on every continent, never see every cloud formation, every coral reef, every desert wind. The continents stretch for thousands of miles. Oceans covering nearly 3/4 of the surface are deeper and vaster than most of us will ever comprehend. Mount Everest climbs nearly 6 miles into the sky. From the perspective of early humans, Earth was the universe. The sky was a dome. The stars were pinholes in a black curtain. This belief didn't come from ignorance. It came from evidence, limited but honest. Stand at sea level, watch the horizon. It does look flat. The curvature is too subtle for the naked eye. From this grounded view, the world seems boundless. Earth has a diameter of about 8,000 miles at the equator. If you could somehow walk around it, yes, even over oceans, it would take you roughly 3 years of walking 8 hours a day at an average pace. That's a long, long journey. The full surface area of Earth spans nearly 200 million square miles. Want a more absurd metric? If you spent 1 second on each square mile of Earth, visiting them non-stop, it would take over 6 years to cover every patch of ground. Sounds vast, right? Let's shrink it. The United States, a country many think of as massive, occupies less than 2% of Earth's total surface. Suddenly, it's not so large. Suddenly, nothing is. Now, here comes the turn. All of that oceans, continents, mountains, empires, you only feels large because our minds were built for walking, not flying. Our intuition is calibrated to the human body, not the structure of the universe. So we measure size based on how long it takes us to cross a room, a country, a lifetime. But start zooming out just a little and Earth begins to contract. Let's visit the moon, our closest neighbor. It orbits Earth at an average distance of about 239,000 miles. That's roughly the distance you'd travel if you circled Earth nearly 10 times. When Apollo astronauts flew there in the 1960s, it took them 3 days to reach it. The moon's diameter is about 2,100 miles, roughly 1/4 that of Earth. If Earth were a basketball, the moon would be a tennis ball. But here's where things get strange. Despite their sizes, the space between them is immense. You could fit 30 Earths in a straight line between our planet and the moon. 30. That's the first real taste of how empty space is. It feels close in our imaginations. But in reality, even the distance to our nearest celestial partner is a void. When you see pictures of Earth and moon side by side, they're often shown unrealistically close, practically touching. But in truth, there's a vast nothingness between them, an emptiness you could fly through for days and still not see land. And that's just the moon. The sun is next. But we'll get there in part 2. Let's pause here. Already, We've walked from the soil beneath your feet to a vision of 30 invisible Earths laid like stepping stones in the void, and we've barely begun. What's important isn't just that Earth is small, it's that we, its passengers, never evolved to perceive that smallness. We live in a world built for survival, for weather, for seasons and shadows, not for understanding cosmic scale. But the cosmos doesn't care about scale from a human perspective. It simply is. And Earth, for all its beauty, all its lush forests and teeming oceans, is a fleck, a whisper, a vibration in the breath of something incomprehensibly vast. Here's the paradox, though. From that whisper came life. From that fleck came Beethoven, and fire, and love, and language, and art. From that tiny blue dot, we've reached into the abyss and begun to map the structure of the entire observable universe. So maybe smallness is not weakness. Maybe it's what makes us precious. Maybe, in a cosmos so vast that Earth is less than a decimal point, consciousness itself is the miracle. We'll keep zooming out, layer by layer, dimension by dimension. But remember this, before we could find ourselves in the stars, we had to realize how nearly invisible we are within them. And yet, here we are, looking up. Let us now turn toward the light, our Sunday, that golden, unwavering circle we often take for granted, rising, falling, rising again. It warms your skin, it grows your food, it sets your circadian rhythms, and it even shapes your idea of time. A day is defined by its presence and absence. But when we shift perspective, something shocking happens. Because the sun isn't just the giver of light and life. It is a monument to scale, a structure so vast that Earth, for all its complexity, becomes a rounding error. The sun's diameter is about 864,000 miles, roughly 109 times larger than Earth's. Wrap your mind around that. You could line up 109 Earths edge to edge across the sun's face. But that only tells half the story. Volume is where the real disparity lies. If you had one of those massive glass jars from a science museum and started dropping in little marbles representing Earth, you could fit over 1,300,000 Earths inside that glowing orb. Think of every continent, every city, every story, every war, every invention, every kiss, and then imagine repeating it more than 1,000,000 times to even begin to fill the Sunday. Still, the sun is considered a medium-sized star, a yellow dwarf, nothing exceptional, and yet it holds 99.86% of the mass of the entire solar system. That includes all the planets, moons, asteroids, comets, and dust. Everything we know. The gravitational grip of this star is so powerful, it tethers worlds billions of miles away. Even icy Pluto, which we'll revisit later, dances to the rhythm of the sun's pull. We orbit it, not out of choice, but because we must. It's not a suggestion, it's law. But here's what's even more profound. We live in the shadow of a fusion engine. Every single second, the sun fuses around 600 million tons of hydrogen into helium. That's not poetic exaggeration, that's physics. Every moment, 600 million tons vanish. And in their place, light, heat, energy, radiance. In 1 second, the sun releases more energy than all of human civilization has produced in its entire history, and it has been doing this for over 4.5 billion years. This power surges outward, across 93 million miles of vacuum. We call that distance 1 astronomical unit, or AU. Light takes just over 8 minutes to bridge that gap. That means, right now, you're basking in sunlight that left the surface of the sun 8 minutes ago. If the sun were to disappear, vanish into nothingness, we wouldn't even know until 8 minutes later. Think of that the next time you watch a sunrise. You're witnessing the past. Now imagine trying to cross that gulf, the 93 million miles from Earth to Sun, by car. At normal highway speeds, it would take you over 175 years to arrive. And that's assuming you never stopped for fuel, rest, or even to admire the cosmic scenery. But some machines do make the journey. NASA's Parker Solar Probe, traveling at speeds over 400,000 miles per hour, will eventually become the fastest human-made object in history. And even at those mind-bending velocities, it still takes months to reach the sun's outer atmosphere. The sun is not just massive, it's turbulent. The surface temperature is around 10,000 degrees Fahrenheit. But the core, where fusion happens, is a cauldron of unimaginable pressure and heat roughly 27 million degrees Fahrenheit. That core is where hydrogen atoms are squeezed so tightly they become something new. It's a forge, a birthplace of light itself. The sun is not always quiet either. Occasionally, it lashes out, erupting in solar flares and coronal mass ejections. These are explosions that hurl charged particles across the solar system. When they reach Earth, they paint the skies with auroras, disrupt satellites, and sometimes, if strong enough, threaten power grids and communications. From Earth, the sun appears gentle, a steady companion, but up close it is violent, chaotic, beautifully dangerous. And yet, without it, we are nothing. But here's the strangest part. Despite its overwhelming presence, the sun is ordinary. Among the stars of our galaxy, it holds no special status. Astronomers call it a G-type main sequence star, a dime a dozen, not the largest, not the smallest, just typical. In fact, the vast majority of stars in the Milky Way are red dwarfs, smaller, cooler, dimmer than the Sunday. And some stars are so gigantic, they make the sun look like Earth looks to us. But we'll get to those later. Let's stay with our sun a moment longer. It's middle-aged, about 4.5 billion years old, and it has about 5 billion years of fuel remaining before it dies. When that time comes, it will swell into a red giant, swallowing Mercury and Venus, and perhaps even Earth. And then it will shed its layers and shrink into a white dwarf, an ember of its former self, cold, dim, fading. The same sun that now sustains all life will one day erase us. That's not a threat. It's not even sad. It's just how the cosmos works. Creation, expansion, decay, renewal. From our place here on Earth, we once believed the sun orbited us, that we were the center of everything. It took generations of observations, arguments, exile, and courage to accept the truth. We orbit it. We always have. And we always will. That was our first cosmic dethronement, the beginning of a new humility and a new kind of beauty. So here we are, circling an ordinary star on a small rocky world, floating through an extraordinary void. We are passengers on a speck, but we're learning to see, and when we look at the sun, not just as a glowing disk in the sky, but as a roaring nuclear giant, we begin to understand not just where we are, but who we are. The light on your skin right now began its journey hundreds of thousands of years ago inside the sun's core. It fought its way outward, bouncing, scattering, wandering, until finally, in a final leap of freedom, it surged across space and landed here, on you. You are touched by light born before the pyramids, before language, before names. That's not poetry. That's astronomy. We leave the sun now, not because its story is over, but because the scale demands it. We pull back, away from its blinding crown, past the orbit of Earth, past the inner planets, each a world unto itself, and we begin to glimpse the wider architecture of our cosmic neighborhood. This is the solar system, and it is vast beyond reckoning. Earth is the third planet from the sun, nestled in a narrow band where temperatures allow liquid water to exist. It is, by cosmic standards, a stroke of exquisite luck. But Earth is not alone in its celestial ballet. There are 3 other rocky worlds orbiting alongside it in the inner sanctum of the solar system: Mercury, Venus, and Mars. Mercury clings closest to the sun, scorched on one side, frozen on the other. Venus follows, wrapped in a suffocating blanket of carbon dioxide, hotter even than Mercury despite being farther away. Then comes Earth, blue and teeming, and then Mars, a scarlet husk where rivers once ran but now only dust remains. These 4 terrestrial planets orbit in relatively tight formation. Even at their farthest, they all lie within 1.5 astronomical units of the Sunday A cosmic hearth. But step just beyond Mars, and a fracture appears. A belt of debris, millions of rocky fragments left over from the birth of the solar system, spins endlessly between Mars and the giants beyond. This is the asteroid belt. And although popular media imagines it dense and dangerous, the truth is the opposite. It is mostly empty space, vast, cold, and quiet. The largest object in this belt is a world called Ceres, about 580 miles in diameter. It's round, shaped by its own gravity, and it's classified as a dwarf planet. NASA's Dawn spacecraft once visited it and found signs of underground ice, possibly more fresh water than all of Earth's lakes combined. But beyond the asteroids lies the domain of the Titans: Jupiter, Saturn, Uranus, Neptune. These are the gas and ice giants, and their scale warps comprehension. Jupiter, first among them, is a beast. It spans over 86,000 miles, in diameter about 11 Earths across. But it's not just wide, it's deep. You could drop 1,300 Earths into its volume and still have space to spare. And Jupiter doesn't just sit there passively, it rules. Its gravitational field is so massive that it reshapes the orbits of comets, deflects asteroids, and acts as both guardian and executioner. Some astronomers believe we owe our very existence to Jupiter, its gravity shielding early Earth from catastrophic impacts. Its most famous feature is the Great Red Spot, a colossal storm larger than Earth, raging for over 4 centuries. Winds howl at over 400 miles per hour at its edge. And yet, in recent decades, it's shrinking. If you were born 100 years ago, it would have been 3 times wider than Earth. Now, it is just over 1.3 Earths in width. Someday, it may vanish entirely. Jupiter has at least 95 moons, and 4 of them, Io, Europa, Ganymede, and Callisto, are worlds in their own right. Ganymede is the largest moon in the solar system, even bigger than Mercury. Europa hides a subsurface ocean beneath its cracked ice, perhaps twice as voluminous as all of Earth's oceans combined, a potential cradle for alien life. Then comes Saturn, Lord of the Rings, slightly smaller than Jupiter, but still able to swallow over 760 Earths whole. Its rings, those shimmering, ethereal bands, are made of ice and rock particles, from the size of sand grains to houses. And yet, those majestic rings are absurdly thin. If Saturn were a basketball, its rings would be thinner than a single strand of hair. Saturn's moon Titan is larger than Mercury and boasts a thick atmosphere. It's the only place in the solar system, other than Earth, with stable liquid on its surface. Not water, though. Titan is so cold that its lakes and seas are made of liquid methane and ethane. It rains hydrocarbons. It has rivers, valleys, perhaps even waves. And then, the outer dark. Uranus spins sideways, its axis tilted at 98 degrees, as though knocked over by some ancient cataclysm. Its poles take turns basking in 40-year seasons of sunlight and darkness. Neptune is last dark blue, wind-ravaged, mysterious. Winds reach 1,200 miles per hour, the fastest in the solar system. A violent world hidden in a frozen silence. Even these distant gas and ice giants pale beside the solar system's true breadth, because beyond Neptune lies the Kuiper Belt, a frozen graveyard of icy bodies. Pluto dwells here, demoted from planetary status, but still beloved. Pluto is only about 1,473 miles across, smaller than Earth's moon. And yet, when NASA's New Horizons spacecraft flew past in 2015, it revealed mountains of water ice, nitrogen plains, and a thin pinkish atmosphere. A world, not a rock. Thousands of such worlds orbit in the Kuiper Belt. Some of them are nearly as large as Pluto. Others are shattered remnants from a more violent age. This region stretches billions of miles outward, but even that is not the end. There is something farther still, a boundary so distant it defies belief. The Oort cloud. We've never seen it directly. No telescope has photographed it, but we know it exists from the paths of long-period comets. A vast spherical shell of icy bodies surrounds our solar system like a cosmic bubble. It begins perhaps 2,000 astronomical units from the Sun and stretches outward to nearly 2 light-years away. That's almost halfway to the next nearest star. At that distance, the Sun is just another star in the sky, a tiny dot. Its gravity barely reaches that far. The objects in the Oort cloud are more like prisoners, on the edge of escape, loosely tethered, drifting, ancient. And Earth? In this scale model, if the Sun were a basketball, Earth would be a peppercorn placed 26 feet away. Neptune's orbit would stretch across an entire football field. The Oort cloud? That's another continent entirely. We live inside this structure, a system of rocks, gas, ice, gravity, radiation, and space, nested within space. Nested within space. It is not just distance that humbles us, it is emptiness. Because even in our own solar system, our backyard, most of what exists is nothing. We are drifting through vast hollows, islands of matter adrift in oceans of void. And yet, somehow, one of those islands woke up. It looked around, and it began to wonder. We now leave the solar system. Not just Pluto, not just the Kuiper belt, not even the invisible drift of the Oort cloud. We go beyond all of it, beyond the warmth, beyond the reach of our star, into interstellar space. And the first thing you notice is this. Distance changes meaning here. It stops being something you walk or fly or even dream about. It becomes mythic, metaphorical, terrifying in its silence. Because the space between stars isn't just far. It is cruelly, absurdly empty. Let's start with the closest, Proxima Centauri. It is part of the Alpha Centauri system, our nearest stellar neighbor, a small red dwarf star, cool, dim, flickering, and it's close by cosmic standards. It lies about 4.24 light-years away. A light-year is the distance light travels in 1 year, about 5.88 trillion miles. So Proxima Centauri is about 25 trillion miles from Earth. 25 trillion. We have no frame of reference for that number. So let's try this. If the Sun were shrunk to the size of a dime, Earth would be a grain of salt orbiting it a few inches away. In that same scale, Proxima Centauri would be another dime 4 miles away. Not a few steps, not a short drive. 4 miles. Now consider this. The fastest object humanity has ever built is Voyager 1. Launched in 1977, it has been traveling for nearly 5 decades, and it is now over 15 billion miles from Earth. A staggering achievement. And yet, at its current speed, about 38,000 miles per hour, Voyager 1 would still need over 73,000 years to reach Proxima Centauri. And it isn't even aimed in the right direction. We sent it out knowing that. We sent it anyway, because that's what wonder does. It moves forward even when the goal is unreachable. But what if we had better technology? Let's say we could build a ship that travels at 10% the speed of light. A sci-fi marvel. It would still take over 40 years to reach Proxima Centauri. And at that speed, even a single grain of interstellar dust could puncture your ship like a bullet. The distances are so unforgiving, so absolute, they begin to resemble time itself, relentless, uncaring, inescapable. And remember, Proxima Centauri is the closest. Most stars are much farther. Sirius, the brightest star in our night sky, is about 8.6 light-years away. Betelgeuse, the red giant looming in Orion, is roughly 700 light-years away. And even these are nearby by cosmic standards. At this scale, Earth doesn't just shrink, it vanishes. If you stood on a hypothetical planet orbiting Proxima Centauri and looked back toward our solar system, you would not see Earth. You wouldn't even see the Sun as anything more than a bright dot lost among billions. Earth is simply too small, too faint, too close to its own star's glare. Invisible, the vastness between stars is not just spatial, it's existential. It's the realization that, for all our ambitions, we are profoundly isolated. And yet, there's something remarkable about Proxima Centauri. Despite being a small, unstable red dwarf, it hosts at least 2 known planets. One of them, Proxima b, lies in the so-called habitable zone, the region where liquid water could exist. but the star flares violently, often bathing its planets in bursts of radiation. If life exists there, it must be built to endure. Still, it's astonishing to think that the nearest star might also host a rocky world, a potential second home, a cosmic echo of our own pale blue dot. Proxima Centauri is part of a triple star system, bound together by gravity. Alpha Centauri A and B are more sun-like. From any planet orbiting one of them, the skies would be filled with twin suns, a spectacle we've only imagined in fiction. But travel remains fantasy. For now, what about other nearby stars? Barnard's star lies about 6 light-years away. Lumen 16, a pair of brown dwarfs, sits just beyond. These systems, too, might hold planets. They are part of our local stellar neighborhood, a loose bubble of stars spanning about 30 light-years across. 30 light-years. Sounds modest, right? But remember, light, the fastest thing in the universe, takes 30 years to cross that space. A human moving at human speeds would never finish the journey. And these are just the stars we can see. Every dot in the night sky belongs to our galaxy, the Milky Way. It holds somewhere between 100 billion and 400 billion stars. Our sun is one of them. Nothing special, not in position, not in brightness, not in size. We live in a minor spiral arm called the Orion Spur, about 26,000 light-years from the galactic center. We are not near the core. We are not near the edge. We are in the suburbs of the galaxy, quiet, sparse, and blessedly stable. That stability may be why we're here at all. The inner galaxy is a maelstrom radiation, supernovae, black holes. But out here, among slow-turning stars and gentle orbits, life had time to arise, to evolve, to ask questions, like this one. If we're so far from everything, are we alone? It's a question that haunts the silence. We've scanned the sky for signals. We've listened for whispers across the void. So far, we've found nothing. But absence is not evidence. The distances are so extreme that even if civilizations were out there, their voices might never reach us, or they may have come and gone long before we ever learned to listen. And perhaps we haven't really begun listening yet. Still, in our own way, we've already touched the stars. We've sent probes into the deep. We've mapped exoplanets by watching stars flicker ever so slightly. We've captured the faint tug of gravity as planets orbit distant suns. We've even photographed planets hundreds of light-years away, tiny crescents orbiting distant points of light. The future of exploration lies not in rockets alone, but in understanding, in precision, in patience, because the universe does not hide, it simply waits. And as we peer outward from our quiet orbit around an unremarkable star, we begin to grasp the truth. We are surrounded by oceans of light-years, by distances so large they defy the physics of instinct. But we are also surrounded by potential, each star a chance, a story, a beginning, and in the midst of all that emptiness, here we are, listening, wondering, daring to hope that someone or something might one day answer. We are now adrift in a vast stellar ocean, beyond the orbit of Pluto, beyond the Oort cloud's icy hush, beyond even the nearest stars. We find ourselves inside something far greater, the Milky Way galaxy. This is not a single place, it is structure, motion, and memory. A colossal whirlpool of stars, gas, dust, and dark matter stretching across 100,000 light-years. A flattened spiral, elegant, radiant, incomprehensibly massive, seen edge-on from Earth as a faint white band in the night sky. And every single star you've ever seen with your naked eye, every one belongs to this galaxy. All the ancient constellations, the stories of Orion and the Seven Sisters, the North Star and the Southern Cross, they are all part of the Milky Way. Our island in the cosmic dark. Astronomers estimate the Milky Way contains between 100 billion and 400 billion stars. That's not a metaphor. That is our address. And yet we live in the quiet part of town. Our sun is located about 26,000 light-years from the galactic center, tucked within a minor spiral arm called the Orion Spur. We are not near any major landmark, not near the dense, glowing core, not near the outermost edge. We reside in a kind of galactic suburb, peaceful, stable, and blessedly uneventful. And that may be why we're here at all. You see, the spiral arms of galaxies are regions of chaos, birthplaces of stars, cradles of fire. The arms burn bright because they are filled with young, hot, short-lived stars. They form quickly and die violently, going supernova and flooding their surroundings with radiation. To live in such regions would be to live beneath constant bombardment. But our sun is older, calmer, and it has had time to drift away from the arm it was born in, into a quieter stretch between spirals. Here, the interstellar radiation is lower, supernovae are rare. Life had a chance to take hold, and then to flourish. From this tranquil vantage point, we orbit the center of the galaxy once every 225 million years. That's our galactic year. The last time the Sun was at its current point in the Milky Way's rotation, dinosaurs were just beginning to emerge on Earth. The time before that, the continents were still joined as Pangaea. Earth has completed about 20 galactic orbits since it formed. The universe itself is only about 60 galactic years old. That is how slowly galaxies breathe. At the heart of the Milky Way lies something both invisible and unimaginable, a supermassive black hole, known as Sagittarius A*. It contains the mass of 4 million suns, compressed into a space smaller than the orbit of Mercury. No light escapes it, but we know it is there, because we can see the stars around it being whipped into incredible orbits, some moving at a significant fraction of the speed of light. This black hole is quiet now, dormant, but it was not always so. Once, it may have blazed like a quasar, devouring gas and stars, lighting up the center of the galaxy in a torrent of radiation. Even now, we find echoes of that ancient violence. Astronomers have discovered enormous gamma-ray bubbles rising above and below the galactic plane, remnants of a time when our central black hole was wide awake. The Milky Way's structure is layered. At the center lies the galactic bulge, a spherical swarm of older stars, densely packed, glowing red and gold. From it emerge the spiral arms, ribbons of newborn stars, star clusters, gas clouds, and interstellar dust. This is the realm of nebulae, of creation and collapse. Surrounding the whole is the galactic halo, a dim, spherical cloud containing ancient stars and globular clusters. It reaches out to about 130,000 light-years. But even this is not the full extent of the galaxy, because enveloping everything is something we cannot see, something that outweighs all the stars, all the gas, all the planets. Dark matter. We don't know what dark matter is, but we know it's there because of its gravitational pull. It holds the galaxy together. Without it, the outer stars would fly away. The spiral arms would unravel. The dark matter halo may extend out 600,000 light-years, or more, an invisible cocoon of mass, anchoring our island in space. And we are not alone. The Milky Way has dozens of satellite galaxies, smaller companions orbiting its bulk. The two most famous are the Large and Small Magellanic Clouds, visible to the naked eye in the southern hemisphere. These irregular galaxies are being slowly torn apart by the Milky Way's gravity. One day, they will be fully absorbed. This is how galaxies grow. They consume. The Milky Way itself was forged from mergers. The evidence is all around us, in streams of stars arcing through the sky, remnants of long-dead galaxies shredded by gravity. And we, too, are headed for a collision. In about 4.5 billion years, the Milky Way will merge with its nearest galactic neighbor, Andromeda. Andromeda is larger than the Milky Way, over 220,000 light-years across, and contains more than 1 trillion stars. It is currently approaching us at a speed of about 110 kilometers per second. The collision will not be like a car crash. The distances between stars are so great that most will pass by without incident. But gravity will tear the galaxies into ribbons, slingshot stars across intergalactic space, and reshape both into a single, giant, elliptical galaxy. It will be a storm of light and silence, a dance of annihilation and rebirth. And Earth? By then, Earth may be gone. The sun will be near the end of its life, but perhaps descendants of humanity or of the life that comes after us will still be there, watching, recording, remembering. Because even when galaxies collide, time moves on. The Milky Way is not unique. Across the universe, galaxies swirl and merge and scatter like autumn leaves caught in a wind of gravity. Some are small dwarfs with only a few billion stars. Others are giants, hundreds of thousands of light years across, containing hundreds of trillions of suns. But each one is a world entire. Each one is a possibility. And we? We are inside one. We are not outside observers. We are citizens of this spiral sea. We orbit, we rotate, we belong. Even though Earth has become invisible at this scale, even though our entire solar system shrinks to less than a speck, our minds stretch outward, our instruments pierce the dust, our questions echo among the arms. We are made of star stuff, as Carl Sagan once said. But more than that, we are the galaxy awake. We have left the Milky Way. It now glows behind us like a single spiral shell in a boundless ocean, just one among hundreds of billions. Its arms spin quietly, its stars continue burning, but we are no longer passengers of a single galaxy. We are voyaging through something far larger, a universe of galaxies. Each dot in the sky we once mistook for a star may be a galaxy, made of countless stars, planets, nebulae, and black holes. And now, we begin to ask new questions. How are these galaxies arranged? Is there a pattern? And what lies beyond? Let's begin with our immediate neighborhood, what astronomers call the local group. It's a modest gathering of more than 50 galaxies, including our own Milky Way, the Andromeda Galaxy, and dozens of dwarf companions. The local group spans about 10 million light-years across. It is the smallest building block of the large-scale universe. The Milky Way and Andromeda are the two giants in this gathering. Each contains hundreds of billions of stars. The others, like the Triangulum Galaxy and the Magellanic Clouds, are smaller, fainter, quieter. The galaxies in our group are gravitationally bound. They orbit one another like dancers in a slow-motion cosmic ballet, set to collide and merge over billions of years. But the local group is just one cell in a much larger body. Zoom out. We now find ourselves inside a vast structure called the Virgo supercluster, an enormous aggregation of galaxy groups and clusters spanning over 110 million light-years. It contains thousands of galaxies, many of them larger and brighter than the Milky Way. Near its heart lies the Virgo cluster, a colossal swarm of more than 2,000 galaxies. There, elliptical and spiral galaxies crash together in crowded chaos. Stars are flung into intergalactic space. Tidal forces stretch entire systems like taffy. This is where galaxies are born and destroyed in equal measure. But even this is not the limit. In 2014, astronomers made a discovery that changed everything. They found that the Virgo supercluster and the local group within it is part of a much larger structure, a gravitational basin called Laniakea. Laniakea, which means immeasurable heaven in Hawaiian, is a supercluster of superclusters. It spans over 520 million light-years, and it contains over 100,000 galaxies. Imagine that. 100,000 galaxies each with hundreds of billions of stars. Each star with a chance for planets. Each planet a chance for life. And Earth? Still just a whisper, a flicker, a question mark. All galaxies within Laniakea are gently flowing toward a mysterious region of space known as the Great Attractor. This is not a single object, but a gravitational anomaly, a zone of immense pull hidden behind the dust and stars of our own galaxy. For decades, it was invisible to telescopes. We only knew it was there because we could feel it. The galaxies around us are moving not randomly, but in unison, like leaves swirling toward the mouth of a drain we cannot see. Today, we know that the Great Attractor is home to multiple massive galaxy clusters, including the Norma cluster, which helps anchor the region's gravitational influence. And beyond the Great Attractor, even more. A further gravitational titan, known as the Shapley supercluster, located about 650 million light-years away, contains thousands of galaxies and may be drawing Laniakea itself into its sphere of influence. It's difficult to describe what this means, because at this scale, even galaxies are too small to matter. The Milky Way becomes a footnote, and Earth is erased. But we are not done yet. Zoom out again. As astronomers began to chart the positions of galaxies on the largest scales, a remarkable pattern emerged. Galaxies are not randomly distributed. They are arranged along vast, curving filaments and walls, forming a kind of cosmic web. The structure of the universe on the grandest scales is not uniform. It is woven. Imagine a spider web made of light, stretching across billions of light years. Galaxies cluster along the threads. Between the filaments lie voids, immense regions of near total emptiness where few galaxies exist. These voids span hundreds of millions of light years across. They are not just gaps, they are deserts of existence. The most massive known filament is called the Hercules Corona Borealis Great Wall. It stretches more than 10 billion light years. That is more than 70% of the radius of the observable universe. It may be the largest structure ever discovered, so large, in fact, that it breaks some models of cosmology. According to current understanding, there should not have been enough time since the Big Bang for gravity to form something this enormous. And yet, here it is. A wall of galaxies, a ripple in the fabric of space itself. These structures, the walls, filaments, and voids, form a three-dimensional map of matter that resembles a living thing. A brain, a neural net, a cosmic nervous system. And Earth? Earth has long since disappeared from view. The Milky Way is a cell, a pulse, a flickering thought in the mind of the cosmos. Let that image linger for a moment, because it raises a profound possibility. Perhaps we are not just floating in a web of galaxies. Perhaps we are part of the web's function. Perhaps consciousness is not the exception, but a consequence. Perhaps the universe is not merely expanding, it is awakening. But that is speculation. For now, we can only observe, and what we see is astonishing. The cosmic web is the skeleton of the universe. It is the structure that formed from the quantum fluctuations of the early universe. Over billions of years, gravity amplified the tiny differences in density. The denser regions pulled in matter, the empty regions grew emptier, and slowly the web emerged, a lattice of light and silence, a geometry of destiny. We float inside this structure. Our galaxy is a node, our star is a spark, and Earth is an atom in the bloodstream of a living cosmos. And yet, against all odds, this atom has become aware of the network that birthed it. We have mapped the threads, we have seen the walls, we have measured the darkness, and we have given it a name, universe. We've been traveling through space. Now we begin traveling through time. Because when we look outward in the universe, we are also looking backward. That is the strange and haunting fact about light. It moves fast. Nothing moves faster, but it does not move instantly. It takes time. And so, everything we see in the night sky is a message from the past. The moon? About 1.25 seconds ago. The sun? Just over 8 minutes. The nearest star? More than 4 years. The Andromeda Galaxy? 2.5 million years. Every time we raise our eyes to the sky, we become time travelers, glimpsing ancient photons that have been crossing the void for epochs. The universe, through light, offers us a kind of memory, and this memory has a limit, the observable universe. It is not the whole universe, only the part we can see, bounded by time and the speed of light. Because the universe has a beginning, a birthday, a moment when time itself turned on. Roughly 13.8 billion years ago, the universe was born. It was not an explosion in space, it was the sudden expansion of space itself. Everything that exists was once compressed into a volume smaller than an atom, a singularity, infinite density, zero distance, no edges, no outside. Then came expansion. Time unfurled, space stretched, and in those first moments, the seeds of everything, stars, galaxies, atoms, planets, people were planted. This is what we call the Big Bang. Not because it was loud, but because it was loudness itself being created. The fabric of space began to swell, and from the earliest quantum ripples came structure, Gravity amplified tiny differences. Matter began to clump. Photons cooled and decoupled. The first light escaped, and we can still see it. We call it the cosmic microwave background, a faint glow spread across the entire sky, the cooled echo of that primordial light. It is the oldest photograph in existence, a snapshot of the universe when it was just 380,000 years old. When we look at it, we are seeing back in time almost to the beginning. But that beginning was not small for long. Since then, the universe has been expanding, and not slowly. You might think that after 13 billion years, the edge of what we can see would be 13 billion light years away. But the truth is, stranger, because space has been stretching the whole time, the observable universe is about 93 billion light years in diameter. Let that settle in. We can see in every direction for about 46.5 billion light years, and every direction is the past. Some galaxies we observe are so far away that their light began traveling toward us when Earth was molten. Others shone their last light before Earth even existed. Some of those galaxies no longer exist. They've been torn apart, merged, extinguished, but their light is still on the way, arriving here, now, into your eyes, into your mind. Think about what that means. We are watching ghosts. We are studying the light of extinction, the most distant galaxies ever seen. Faint smudges captured by the James Webb and Hubble space telescopes, shown over 13 billion years ago, when the universe was in its infancy. These are not just old stars. They are ancient intentions, frozen in motion, stretched by time. We measure their distance not just in miles, but in redshift, a fingerprint of how much the light has stretched as space itself expanded. The farther away the source, the longer its light waves become, the more ancient it is. The deeper into time we peer, this expansion of space is not slowing, it is accelerating. That discovery made in the late 20th century was so unexpected it shook cosmology. Something unseen, unknown, is pushing galaxies apart faster and faster. We call it dark energy. We don't know what it is, but we know it exists because it leaves fingerprints everywhere, in the light, in the motion, in the stretch. Dark energy now makes up about 68% of everything. And what does that mean for the future? It means the universe is not slowing down on its way to some eventual collapse. It is racing apart. Galaxies are slipping beyond our reach. Stars that shine today will one day be invisible, not because they faded, but because their light will never reach us. Their space will have stretched too far, too fast. Eventually, only the nearest galaxies, the few bound to us by gravity, will remain visible. The rest of the cosmos will dissolve into darkness. This is not a guess. This is the future we are headed toward. A future of isolation. And after that, in about 100 trillion years, all star formation will cease. The universe will enter the degenerate era. Black dwarfs and white dwarfs will remain. Then, even those will fade. In time, unimaginable time, black holes themselves will evaporate via Hawking radiation. The universe will end not with a bang, but a whisper. Cold, empty, silent. A vast stillness, but not yet. Now, it is still alive, brilliant, expanding, singing. We can still see, still remember, still ask questions. We are alive in a time when we can witness the full structure of the cosmos from birth to now. We can study the fossil light of the Big Bang. We can map the echoes of galactic collisions. We can calculate the fate of stars yet unborn. And Earth? Still gone at this scale. Still beneath notice, but not beneath meaning. Because we are here, not just as witnesses, but as narrators. We are the part of the universe that can look back and see how far we've come, not just across space, but across time. We are memory. We are observers. We are the light remembering itself. And the light, somehow, looks back. Let us fall back now from superclusters and gravitational rivers, from filaments of galaxies and dark energy's quiet push. Let us return, not just through space, but through time, and focus our lens on a single, pale dot suspended in all that blackness. Earth. For all the distances we've traveled, all the scales we've magnified beyond comprehension, This is where the story becomes personal. This is where stardust learns to breathe. The Earth formed about 4.54 billion years ago. It was born not from tranquility, but from violence. The early solar system was a maelstrom of molten rock, collapsing gas, and collisions so vast they reshaped entire planetary bodies. Our sun had only just ignited its nuclear heart, turning on, fusing hydrogen, casting light into the void. Around it, a disk of debris spun chaotically. Dust became pebbles. Pebbles became boulders. Gravity gathered them into planetesimals. These primitive building blocks slammed into each other, growing hotter with each impact, melting, fusing, tearing apart, and fusing again. In this crucible, Earth was born. But it did not yet resemble the world we know. In its infancy, Earth was a fireball, its surface, an ocean of magma, its sky thick with carbon dioxide, ammonia, and methane. There were no continents, no oceans, no blue, no green, no life. And then something happened. An object roughly the size of Mars, what scientists call Theia, crashed into Earth in one of the most cataclysmic events in planetary history. The collision was not a glancing blow. It was total. Molten rock and metal exploded into space. A ring of debris formed around the ruined Earth, and over time, weeks, perhaps months, that debris coalesced into the moon. Yes, our moon, born not alongside Earth, but from Earth. And ever since, it has hung in our sky as a silent twin. Its presence has been more than poetic. It stabilizes Earth's axial tilt, regulates our tides, and may have helped life gain a foothold in the chaotic early oceans. But even after the moon was born, Earth was still unrecognizable. Volcanoes choked the skies. The atmosphere was thick with carbon dioxide. The surface was bombarded by asteroids. And yet, it cooled. The crust hardened. Water arrived perhaps from cometary ice, perhaps from within. Clouds formed, and the first rains fell. Imagine it. After millions of years of fire, the first drops of rain landing on still warm stone, steam rising, oceans collecting, a planet beginning to remember calm. And it was in those oceans that life began. We do not know exactly how. The details remain one of the great unsolved mysteries of science. But somewhere, between the tides and thermal vents, chemistry became biology. Non-living molecules assembled into something that could replicate, something that could change, something that could evolve. It was not dramatic. The first life was simple, single-celled, fragile, invisible, but it was alive. That moment when lifeless matter gave rise to living systems was perhaps the most profound transformation in the history of the universe. For billions of years, life remained simple. Cells divided, mutated, adapted. Some learned to capture sunlight, others learned to eat. The Earth slowly transformed, not through geology, but through biology. Then came a miracle. Some microbes developed the ability to produce oxygen as a byproduct of photosynthesis, and slowly, over hundreds of millions of years, they filled the atmosphere with it. Oxygen is a highly reactive, dangerous gas. At first, it killed many forms of early life, but it also enabled more complex chemistry. With oxygen, energy could be harvested more efficiently. Complex life became possible. And then, around 600 million years ago, something extraordinary happened: the Cambrian explosion. In a geologically brief moment, the oceans exploded with new forms, animals with skeletons, shells, eyes, limbs. The biological imagination had been unleashed. From there, life diversified. Fish, plants, insects, amphibians, reptiles, dinosaurs. Earth became a living canvas. Forests rose, coral reefs flourished, the air thickened with wings, and still, the clock of extinction ticked steadily. Catastrophic impacts, climate shifts, volcanic winters. 5 major extinction events reshuffled life's story, wiping out entire branches of the tree. But from each collapse came renewal. Life, once ignited, was resilient. Then, Just 300,000 years ago, an eye blink in cosmic time, something unexpected appeared. A new kind of primate. It walked upright. It made tools. It painted caves. It asked questions. Homo sapiens had arrived. The human story, for all its triumph and tragedy, is a footnote in Earth's deep history. If you compress the Earth's entire existence into a single year, humans would emerge in the last hour of December 31st. Recorded history? The final 10 seconds. And yet, in that flicker, we learned to shape the land. We built cities. We crossed oceans. We split the atom. We reached into space. And we began to understand where we are. That this planet we call home is not the center of the universe. That we orbit a star. That our star is one of billions in a galaxy. That our galaxy is one of trillions in a web that stretches to the edge of time. And that Earth, this thin blue membrane of ocean and atmosphere, is the only place, so far, where the universe has given rise to consciousness. We are not the rulers of Earth. We are Earth. We are the atoms it assembled to look back on itself. We are the memory of stardust, the voice of stone, the ocean learning to speak. So far, we've journeyed outward into galaxies, into gravity, into time. We've zoomed out far enough to see Earth vanish. Now we zoom in again, not in size, but in significance, because even after everything, the swirling stars, the endless filaments, the superclusters pulling on superclusters, Earth remains the only place we know that hosts life. And more than life, consciousness. Why? What happened here, on this planet, that didn't happen elsewhere? Let's begin with the basics. Earth is not the biggest, nor the oldest, nor the most chemically complex planet. It is, in many ways, average. And yet, life diverse, intelligent, self-aware blossomed here. It began with water. Earth is at just the right distance from its star, close enough to stay warm, far enough not to boil. We call this the habitable zone, sometimes, poetically, the Goldilocks zone. Not too hot, not too cold, just right. Earth's atmosphere retained the right balance of gases: nitrogen, oxygen, carbon dioxide. Its magnetic field, born from the churning iron core beneath us, shields the surface from solar radiation. Its moon, large for a planetary satellite, stabilizes Earth's tilt, moderating climate cycles. Its crust is fractured into plates, enabling a slow dance of continents. This plate tectonics recycles carbon, regulating temperature over geologic time. It is a thermostat written in rock. None of this is guaranteed. Mars, too, once had rivers. It lost its magnetic field, and with it, its atmosphere. Now, its surface is cold, arid, exposed. Venus is Earth's twin in size, but its atmosphere is a tomb thick with carbon dioxide, hot enough to melt lead. Earth, by some alchemy of accidents and constraints, remains alive. But perhaps life is not so rare. Perhaps it simmers beneath the frozen oceans of Europa. Perhaps it hides in methane lakes on Titan. Perhaps it thrives in the atmosphere of some distant exoplanet we haven't yet discovered. Since the early 1990s, astronomers have confirmed over 5,500 exoplanets, planets orbiting other stars. Some are hot Jupiters, massive and fast, orbiting close to their stars. Others are icy, rocky, gaseous, super-Earths, mini-Neptunes, and mirror worlds. Some lie within their stars' habitable zones. Some are scorched, some frozen, and some, just maybe, are like us. Based on data from telescopes like Kepler and TESS, it is now estimated that the Milky Way alone may contain billions of Earth-sized rocky planets in habitable zones. Billions. And yet, nothing, no signals, no artifacts, no visible signs of technology, no whispers across the dark. This is the Fermi paradox, named after physicist Enrico Fermi, who asked one lunchtime in 1950, "Where is everybody?" If the universe is ancient and vast, and if life is common, and if intelligence leads to technology, then where are the civilizations? The starships? The megastructures? The beacons? Why is the sky so quiet? Many answers have been proposed. Some believe intelligence is rare. that while life may be common, the leap to minds like ours is vanishingly improbable. Others suggest civilizations self-destruct. That intelligence leads inevitably to war, to environmental collapse, to silence. Perhaps they are out there, but not broadcasting, observing quietly, or using communication methods we cannot yet detect. Perhaps they are so far ahead of us, we are indistinguishable from static. Or perhaps space is simply too vast. Even a signal traveling at the speed of light takes years to reach nearby stars, centuries to reach the outskirts of our galaxy. A message sent might take millennia to arrive. A response? Another millennium. And so, even in a universe full of life, each world might remain effectively alone. Or maybe we are first. The first spark of consciousness. The first to send probes, build telescopes, contemplate the void. If that's true, then we are not insignificant. We are foundational. We are the first eyes of the universe, opening slowly in the dark. But there's another possibility, one that is both hopeful and humbling. That life, especially intelligent, technological life, is so rare that Earth may be one of only a handful of planets in all the observable universe where matter has awakened. Not because we are special, but because we are lucky. Right conditions, right chemistry, right timing. And if that's true, if consciousness is truly rare, then what happens here matters more than we can imagine. Because it may be the only place where the universe knows itself, where atoms have learned to question their origins, where carbon speaks, dreams, invents, mourns. What does that make us? It makes us fragile, but it also makes us precious. Not just Earth, but the biosphere. It sustains the forests and coral reefs, the whales and dragonflies, the mycelial networks beneath the soil, the bioluminescence in the ocean's depths, the birds that migrate across hemispheres, guided by magnetism and memory. Each extinction, each collapse of an ecosystem is not just a local tragedy. It might be a cosmic loss, because we do not know how many Earths there are. We do not know how many voices the universe contains. We only know ours. And if this is the only voice, the only melody sung in a cathedral of silence, then we must treat it with reverence. We must protect it, preserve it, nurture its curiosity. Because if life is rare, and if we are among the first, then we carry not just our own story, but the potential of all stories yet to come. One day, perhaps, we will find others. Perhaps a signal will come a whisper from across the light years, or perhaps we will be the ones to send it, to light beacons on exoplanets, to carry the DNA of Earth into the stars. But until then, this planet is all we know. This sky, this sun, this silence, and yet, in that silence, we have discovered so much. We have measured the age of stars, mapped the geometry of time, unveiled the atom, split the spectrum of galaxies, and perhaps, most important of all, we've begun to realize our own responsibility to each other, to this world, to whatever watchers may one day follow. We are Earth's memory, Earth's voice, Earth's chance, and perhaps the universe's. We have looked outward for so long into galaxies, stars, and the cosmic web that it's easy to forget the other direction, inward. If we turn our gaze not to the vastness of the universe, but to its smallest scales, a different kind of wonder emerges. Because the more we shrink our focus from mountains to minerals, from cells to molecules, from atoms to particles, the more we find a truth that is as humbling as any galactic collision. Everything is mostly empty. Let's begin with the familiar. Earth is solid. Yes, you feel it beneath your feet. The chair holds your weight. Your body occupies space. But what is it made of? Atoms, the building blocks of all matter. Everything you've ever touched, tasted, seen, or been is made of atoms. And atoms are mostly nothing. A typical hydrogen atom, the simplest there is, consists of a single proton at the center, orbited by a single electron. But the electron does not behave like a tiny planet circling a sun. It exists as a probability cloud, a region of space where the electron might be, and between the nucleus and that cloud, empty space. To understand the scale, Imagine the nucleus of an atom as the size of a peanut. On that scale, the entire atom would be the size of a football stadium. The electron would be somewhere near the outer wall, flickering in and out of knowability. The space between the nucleus and the electron is vast. Proportionally, it's as empty as the space between planets. Now multiply that emptiness by the trillions of atoms that make up your hand. You are, in the most literal sense, a ghost made of force fields. You are not solid because of matter. You are solid because of electromagnetic resistance. The electrons in your hand repel the electrons in the chair. That resistance creates the illusion of contact, but matter never really touches matter. It dances near itself. Now let's dive deeper. The nucleus of an atom, tiny though it is composed of protons and neutrons. These are not indivisible. Inside them live even smaller particles, quarks. Protons and neutrons each contain 3 quarks, held together by particles called gluons. Quarks come in different flavors: up, down, strange, charm, bottom, top. Everything you've ever known is made mostly of up and down quarks. But here's the staggering part. Even protons, these dense little cores of the atom, are mostly empty too. The mass of a proton doesn't come just from its quarks. In fact, if you add up the mass of the quarks inside a proton, you only get a tiny fraction of the total. The rest of the mass, the majority, comes from energy, from the dynamic interaction between quarks and gluons, from motion, from vibration. In other words, matter is not just made of particles, it's made of relationships between particles. It's made of motion, of tension, of fields, of energy. And even space itself is not truly empty. The vacuum of space is filled with quantum fluctuations, brief appearances of particles and antiparticles, flickering into existence, borrowing energy from nothing, and vanishing again before they can be caught. This is not science fiction. It is measurable. It is real. So what is a thing? What is a solid object in this framework? It is a pattern, a stability within chaos, a self-reinforcing field of probabilities that persists long enough to be experienced. You are not an object. You are an arrangement, a song played on the fields of spacetime. Let's return to scale for a moment. If you could remove all the empty space from the atoms in your body, compressing every nucleus against every other nucleus, you would shrink down to something smaller than a grain of rice. And if you did the same to all the atoms in the entire human race, compressing every person to nuclear density, you could fit all of humanity into the volume of a sugar cube. Let that sit with you. Everything you've ever loved, hated, hoped for, fought for, all the wars, and art, and memory of the human story, reduced to a sugar cube's worth of compressed matter. This is not metaphor, it is physics. And it tells us something deeper. What matters is not how much matter there is. What matters is how it is arranged. That's what makes Earth more than rock. That's what makes a mind more than molecules. That's what makes a life more than cells. And what about the stuff we can't see? We know that atoms make up only about 5% of the universe's total content. The rest, about 27%, is dark matter, an unknown substance that has mass, bends, gravity, shapes galaxies, but does not interact with light. We cannot see it, but we know it's there by how galaxies rotate and how clusters bend the light of more distant galaxies behind them. The final 68%? Dark energy, the mysterious pressure driving the accelerated expansion of the universe. We don't know what it is. We only know it exists. So let's reframe everything. The stars, planets, nebulae, all the luminous beauty we've explored make up less than 5% of everything. The rest is unseen, unknown, unlit. We are made of the rarest material in the universe, visible matter. And even that matter is almost entirely empty. And still, from that emptiness we emerge, not just as forms, but as experiences, as perception, as awareness, as curiosity. You are a lattice of quantum fields. You are a ripple in a probability wave. You are space and energy pretending to be solid. And still, you wonder, and that may be the most miraculous structure of all. Let us now turn our gaze to the unfolding of time, not cosmic time, but Earth's time. not billions of galaxies expanding through void, but the slow heartbeat of a single planet. A world that began in molten violence, and somehow, over billions of years, grew forests, oceans, lungs, wings, and thought. We often speak of time as something abstract measured in numbers, kept by clocks. But on Earth, time is not a number. It is a story. A story written in stone and fossil, in DNA, in the strata beneath your feet, in the drift of continents, in the changing light of each season, in the slow sculpting of wind and glacier. Earth is not just a world, it is a clock, and life is the ticking hand. The Earth formed about 4.54 billion years ago from the dust and chaos left behind by a young Sunday. In those early days, time moved like fire fast, destructive, relentless. Asteroids rained from space. Volcanoes boiled oceans back into steam. The moon was closer, looming enormous in the sky, pulling tides like breath. But the clock was already ticking. Time moved, and life waited. The oldest evidence we have of life dates to about 3.8 billion years ago, a world still raw, still scarred by impacts, but cooling. And there, in the ocean's depths, life began, single-celled, simple, ancient. For nearly 3 billion years, nothing more than microbial life existed. No plants, no animals, no nervous systems or senses, just life learning to endure. Some microbes developed photosynthesis, capturing sunlight, releasing oxygen. At first, the oxygen was absorbed into rocks, rusting the planet red. But eventually, it accumulated in the atmosphere, transforming the sky into something transparent and blue. It was a revolution, one of the most radical in Earth's history. Oxygen poisoned many early life forms, but it also made way for something new: complexity. It allowed life to grow larger, to breathe, to move, to think. Then came a great acceleration. About 600 million years ago, life exploded in diversity. The Cambrian explosion. In the blink of geological time, Earth's oceans filled with strange, alien creatures, some with eyes, some with armor, some with segmented bodies, swimming, crawling, hunting. This was the beginning of the animal world. From there, the story moves like poetry. Life crawled from the seas onto land, ferns and forests rose, insects took flight, reptiles emerged. Then, about 230 million years ago, came the giants, dinosaurs. They ruled Earth for over 160 million years, far longer than humans have existed. They witnessed the drift of continents, the opening of oceans, the rise of flowering plants, but even their dominion had an end. About 66 million years ago, a rock from space struck the Yucatan Peninsula. In moments, the age of dinosaurs ended. Forests burned, ash darkened the skies, oceans acidified. 75% of all species vanished. But extinction is not just an ending, it is also a clearing of the stage. From the ashes rose mammals, and among them, a lineage of primates. One branch evolved larger brains, finer hands, deeper voices. Eventually, it looked up. Homo sapiens, modern humans, appeared about 300,000 years ago. We spread across Africa, then across the planet. We hunted mammoths, painted caves, buried our dead, named the stars. Civilization, as we know it, emerged only 6,000 years ago, a blink in time's eye. And yet in that blink, cities rose, empires fell, languages were born and lost, philosophies written, technologies forged, cathedrals carved, satellites launched. In the last few centuries, we began to understand what the stars are. In the last few decades, we began to map the genome. In the last few years, we began to simulate minds. It is staggering. Compress Earth's history into a single calendar year, starting January 1st with Earth's formation and ending on December 31st at midnight. Life begins in late March. Complex animals appear in early December. Dinosaurs rule from December 13th to the 26th. Humans emerge at 11:56 p.m. on December 31st. The entirety of recorded human history, the last 10 seconds. That is what we are, a breath at the end of the year, and yet in that breath we have touched the moon, split the atom, composed symphonies, painted galaxies on cave walls and digital screens. We are not the product of inevitability. We are the product of deep time, a million chances, layered and delicate, branching into now. Our bones remember water, our skin remembers sunlight, our minds remember fire, and all of it, every leaf, every footprint, every song, is part of Earth's unfolding time. But time is not only behind us, it is ahead. If humanity survives, Earth's future could be long. The continents will drift. In about 250 million years, a new supercontinent may form. Mountains will rise, oceans will change. In about 1 billion years, the sun will grow brighter, the oceans will begin to evaporate, Earth will slowly become uninhabitable to complex life. In about 5 billion years, the sun will swell into a red giant engulfing Mercury and Venus. Earth may survive, scorched and barren, or it may be swallowed entirely. Eventually, the sun will collapse into a white dwarf. Earth, if it still exists, will orbit a pale, fading ember. Time does not stop, but life may, unless we become something new, unless we carry life beyond Earth, unless we seed other worlds, unless we endure not as a species, but as a story, a continuation of Earth's breath, a ripple in time, because this world, with all its storms and soils and symphonies, was not given meaning by the cosmos. We gave it meaning, and that is what time has built here, not just mountains and fossils, but awareness, not just memory, but the ability to remember, to look back on stars, to imagine forwards, to see all of this not as random noise, but as narrative, as a timeline, as a gift. We began with a question. How small is Earth, really? We've spent hours traveling through galaxies, through atoms, through time. We've walked the glowing filaments of the cosmic web and sailed into the dark between the stars. We've peeled back the layers of space, of matter, of mind. And now we return to that small blue dot and to a deeper question. If Earth is so small, why does it matter? Let's rewind one final time. From the vantage point of the observable universe, some 93 billion light-years across Earth does not register. Even the entire Milky Way becomes a pinprick in that scale. Earth is not just small, it is vanishing. Compared to the largest structures we know, like the Hercules Corona Borealis Great Wall, which stretches over 10 billion light-years, Earth is smaller than a grain of sand in the Sahara. No, it is smaller than a molecule in that grain, smaller than an atom. It would be like trying to find a single cell on a planet the size of Jupiter, using your fingertips in the dark. You can't. Earth disappears, and yet we are here. And that changes everything. In 1990, the Voyager 1 spacecraft, then sailing beyond the orbit of Neptune, turned its camera back toward the solar system, and from a distance of nearly 4 billion miles, it captured an image of Earth. It appeared as a single pixel, a pale blue dot caught in a shaft of sunlight scattered by the camera lens. That image became iconic. But more than that, it became a kind of mirror. Carl Sagan reflected on it this way. Look again at that dot. That's here, that's home, that's us. Every human being who ever was lived out their lives there. Every king and peasant, every saint and sinner, every artist, soldier, wanderer, mother, child, villain, poet, all of human history, on that pixel. And if you step back even further, not just from the sun, but from our galaxy, Earth becomes immeasurably small, smaller than anything we can describe, smaller than words can hold. And still, here we are, looking out, asking questions, making meaning. We are not the center of the universe. We are not even a notable part of it. But we are, as far as we know, the only part that can know, that can contemplate its own insignificance, that can feel awe, and that makes us important in a way that has nothing to do with size. Because if the universe has any awareness of itself, it is through us, through eyes that evolved from cells that evolved from oceans that condensed from dust that came from stars that came from the Big Bang, from chaos to consciousness, from randomness to reflection, and that gives us a weight that size cannot measure. What have we learned on this journey? That everything is bigger than we thought, that even the tiniest things, atoms, quarks, time itself, hide depths beyond imagining, that the light from galaxies takes billions of years to arrive, that there are more stars than grains of sand on Earth, that most of the universe is made of dark matter and dark energy forces we do not yet understand, that our planet is rare, that our life may be rare, that our moment is fleeting, and that our awareness of it all may be unique. So, what now? What do we do with this cosmic perspective? Do we shrink in despair? Do we see ourselves as meaningless, lost in the dark? Or do we understand that in a universe of silence, even a single voice matters? That the fragile biosphere of Earth is not just a planetary quirk, but a sanctuary of complexity in a cosmos dominated by radiation and rock? That kindness matters. That thought matters. That beauty matters. Because it is rare. Because it is temporary. Because it may not happen again. We live on a speck, but this speck thinks. It creates. It remembers. We are not cosmic rulers. We are not cosmic dust. We are cosmic witnesses, and maybe cosmic storytellers. Our job is not to conquer the universe, but to understand it, to treasure what we are, to care for the earth not just as property, but as a miracle. Because even if we one day terraform Mars, even if we colonize moons, even if we seed other star systems with life, Earth will always be the origin, the cradle of consciousness, the place where silence broke. And even if there are others out there, other minds, other worlds, other awareness, we are the ones here now. And that means something. It means that how we treat this planet, this biosphere, each other, is not just a moral choice. It may be a cosmic one, because if we destroy ourselves through indifference, war, pollution, greed, we don't just lose our future, we may silence the only voice the universe has ever had, or at least the first. And maybe that's enough to act differently, to listen harder, to love deeper, to pause now and then, and just look up at the stars, not to find your destiny written there, but to remember that you are part of something so vast, so intricate, so improbable, that even existing within it is a kind of gift. You are made of star stuff, yes, but more than that, you are star stuff with memory, star stuff with questions, star stuff that knows it is small and chooses to care anyway. In the end, Earth is tiny, smaller than an atom compared to the great wall of galaxies. But what matters is not where we are, it's what we are, and who we may become if we endure, if we grow, if we remember, if we protect, then even this small world may be the seed of something far greater, a whisper that becomes a song, a spark that becomes a flame, a dot that becomes the origin of meaning. So, sleep well tonight, traveler of the cosmos. You are not lost. You are home. And home, it turns out, was always more than enough. Thank you for traveling through the universe with me. If this story moved you, if it made you think, or feel, or breathe a little deeper, then consider sharing it. Because this voice, this perspective, this wonder, it belongs to all of us.